Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to be talking about various arithmetic operations on matrices, right? So we're going to start with the first operation on matrices. So this video is about operations on matrices. So the first operation that I would like to talk about is addition. That how do you actually add two matrices? It's actually very simple. Now the first thing that should match, that if you're actually adding, let's suppose I'm adding two matrices, matrix A and the matrix B. Now if I'm adding these two matrices, the only condition that has to be met for me to add these two matrices is that they should be of the same order, right? So then only they can be added. If they are not of same order, then the addition will not be defined. So the addition is not defined if they are not of same order. So which means, let's suppose for example, if I want to add this matrix here, that is 1 2 3 4 5 6. I want to add this matrix with 1 1 1 1 1 1. So if I kind of want to add, so 1 plus 1 will actually become 2, 4 plus 1 will become 5, 2 plus 1 will become 3, 5 plus 1 will become 6, 3 plus 1 will become 4, and 6 plus 1 will become 7. So this is what the addition of the matrix will actually look like. And a very important thing, that the matrices are supposed to be of the same order. If they are not of same order, then A plus B is not defined. So generally, if I want to talk about, let's suppose matrix A, it's this is A11, this is A12, this is A13, and I want to add it with, let's say, this matrix here, that is sorry about that. So A11, A12, A13, and then this is 2 3, right? And I want to add it with B matrix, which has B11, B12, and B13, and B21, B22, and B23. Now the only way I can actually add them, if they are of the same order, you can clearly see that they are of the same order, then A plus B matrix will actually be equal to A11 plus B11, A12 plus B12, A13 plus B13, A21 plus B21, so on like this. So this is how your addition matrix is going to look like. So that's first operation on matrices. What about the second type of operation that I want to talk about? It's a multiplication of a matrix with a scalar number. So multiplication with a scalar. So let's suppose if I want to say, for example, I have this matrix here that is 80, 60, 40, and 20. I want to multiply this matrix by 2. So that is actually going to become 2 into 80 and 2 into 40 and 2 into 60 and 2 into 20. So this 2 is going to actually get multiplied by every element in the set, right? So that is there. That is how you find the multiplication of a matrix. So let's suppose if I have this matrix here, A11, A12, A21, and A22. If I multiply this by K, the resultant multiplication would be K times A11, K times A12, K times A21, and K times A22. Right? So that is known by the multiplication with the scalar number. Similarly, if I multiply a matrix, let's suppose this is 1 2 negative 2 and 1. If I multiply this matrix with a negative number, then it's going to be, all the numbers are going to get multiplied by -1, and this is what I'm going to have, right? So this is something which is also known as the negative of a matrix, right? So this is something which is known as the negative of a matrix, right? So I suppose you're understanding this point over here. Now another thing that I would like to talk about, another operation, is actually the difference between the matrices, which is also very simple. The difference between the matrices, let's suppose you have this matrix here that is 1 2 3 and 2 3 1, and you want to subtract another matrix. Again, both the matrices should be of the same order. That is again very important, right? So if, let's suppose, I want to find the value of A minus B, then that is going to be equal to 1 minus 3, that is -2, 2 minus 1, that is 3, 3 minus 3, which is 0. So you're going to subtract the same element, same corresponding element. 3 minus 2, 1, 1 minus 3, that is -2. So that is going to be equal to A minus uh, B here, right? Now again, there are few properties of addition that that you have to know. So few properties of addition of matrices. So the first property is that the matrices follow the commutative law. So what does the commutative law states? That the commutative law states that matrix A plus B is going to be equal to matrix of B plus A, which is actually very simple. The second is that it follows the law, or the associate law as well, that is A plus B plus C is actually going to be equal to simply A plus B plus C, which is actually pretty obvious. I don't want to show you any kind of proof or law for that. The third thing is that there is actually if you have the K times matrix A plus B is actually going to be equal to K times A plus K times B, right? So these are some of the important properties. It's pretty obvious, but something that you should definitely know, right? So I suppose you're understanding all that part here. So we're only going to do something which is practical enough and something which is worth sharing in this video. Now let's go ahead and understand the multiplication of matrices. So now we're going to find the multiplication of two matrices, right? So before we start, I'm going to start with an example, right? So let's suppose the example is that, again, I'm going to use the same example, that there are three people. Let's suppose the name of the people are X, Y, and Z, right? These three people, they have let's say we talk about pens. He has 2 pens, 3 pens, and 4 pens. And let's talk about pencils, right? Let's suppose he has 5 pencils, 6 pencils, and 7 pencils. And we have, let's suppose the costs of these pens and pencils. At shop 1, let's suppose at shop 1, the cost of a pen, it's let's suppose $8, and the cost of a pencil, it's let's suppose $9. And at shop 2, the cost of a pen is let's suppose $10, and cost of a pencil, it's let's suppose $11. And I want to find out what is it gonna cost X, Y, and Z to buy pencils and pens from shop 1 and buy pencils and pens from shop 2. So I'm gonna have my matrix here. First I'm gonna talk about let's suppose I'm talking about X and Y and Z. So X has 2 pencils and 2 pens and 5 pencils. Y has 3 pens and 6 pencils. Z has 4 pens and 7 pencils. And I have 2 shops with me here. Let's suppose that since I'm talking about pens and pencils only, let's suppose shop 1 has 8. For shop 1, the pencils cost $8 and the pens cost $8 and the pencils cost $9. And for shop 2, the pens cost $10 and the pencils cost $11. And I want to find out what is it gonna take, what is going to be the total cost for X, Y, and Z. What is going to be the total cost for X, Y, and Z for pens and pencils for shop 1 and shop 2? So what is going to be the total cost for them for their respective shops? Now if I try to find the cost for X for shop 1, it's going to be 2 pencils at the rate of 8, which is going to be 2 into 8, plus 5 pencils at the rate of 9, which is going to be 5 into 9. Then for Y, it's going to be 3 pencils at the rate of 8, which is going to be 3 into 8, and then this is going to be 6 into 9. And for Z, it's going to be 4 into 8, and it's going to be equal to 7 into 9. For shop 2, for everyone, for the shop 2, it's going to be 2 into 10, and then it's going to be 5 into 11, right? And for Y, it's going to be 3 into 10 and 5 into 11, so it's going to be a plus. And for Z, it's going to be equal to 4 into 10 and plus 7 into 11. So that is what the total cost is going to be for 1 and 2. So what did we just do? We just multiplied these two matrices and then we got their respective this there. So what did we do? Over here we kind of multiplied this column, sorry, this row with this column here, and we got this, right? Then what did we do? We kind of multiplied this with this, again we got this, and we multiplied this into this, and then we got this. Similarly, we multiplied this into this here, and we got this, and we got this in the same way. Which means at the end of the day, what are we doing? We are multiplying the the rows here, or let's suppose the first element from each column here. You can clearly see that this is the first column, this is the second column. So we are multiplying the first element from each column with the first element of each row from here, and then we are multiplying the first element from each column with the second element of each row from here, and the third element from each column, the third element from each column with the first element from each row from here. So that is what we're doing, and we actually got this, and this is how we actually multiply two matrices. So let's suppose if I have a matrix, let's suppose the matrix is A, B, C and D, right? And I have another matrix, let's suppose D, E and F. So what is going to be the, what is going to be the multiplication of these two matrices? So what I'm going to do is I'm going to multiply this into this here. So it's going to be A into E plus B into F, and then we're going to multiply this into this here, which is going to be C into E plus D into F, and this is going to be the the multiplication of these matrices. Now what is the order of this matrix? It has three rows and it has two columns. You can clearly see it has three rows and it has two columns. Over here it has two rows and it has two columns, and our matrix also has two rows and two columns. In this case it has two rows and two columns, and it has two rows and one column, and overall our matrix again had two rows and one column. So what do you make up out from here? Now one thing that is very important, that this information should exactly match this information. I'm going to do it right here. So let's suppose I have this matrix. This information should exactly match this information in a matrix, so that we're actually able to multiply each element with its element here. We're actually able to multiply this element with each element. We're able to correspond these elements with these elements, which means when we multiply A into B, the number of rows, let's suppose this is M into N, and let's suppose this is, P into Q. So the number of columns for this matrix A, so the number of columns for this matrix A should be equal to the number of rows for this matrix. So that should be equal to the number of rows for this matrix B, right? Why is that? Because this information should completely match this information. So that means if I have a matrix A with an order of, let's suppose, M into N, and I have matrix B with an order of, now we know that this N should actually be an N here. We have another matrix with an order of N into, let's suppose, P. So A and B, the matrix A into B will actually give us an order of M into P here. It will actually give us an order of M into P. If you can clearly observe that this 2 is actually equal to this 2. This is actually 3 into 2 because there are 3 rows here. So this 2 is actually equal to this 2, and we got a matrix of 3 into 2 here. As you can clearly see, this is 3 into 2 here. Similarly, this 2 was equal to this 2, and we had a matrix of 2 into 1 here and 2 into 1 here. So that means the only way the product of two matrices would be defined when this information completely matches this information. That means that the number of columns of first matrix, which is actually getting multiplied with the second matrix, is actually equal to the number of rows of the other matrix. Then only A and B will be defined. So let's go ahead and kind of generalize this. So let's suppose I have a matrix A which is defined as A of 1 1, first row and the second column, first row and the second column, first row and the first row first column, first row second column, first row third column, and it's actually the nth row and the this is the first row and the nth column. Similarly, I'm going to have the mth row and the first column, and I'm going to have mth row and the nth column. So it's of the order mn, and matrix B, in order for it to be a valid multiplication, this has to be an order of n into p, where the number of columns here should actually be equal to the number of rows. So this is going to be b of 1 1 all the way till b of 1 and p. This is going to be all the way p of n into 1 and b of n and p. Now the product here, it's actually going to look something like this, right? So this row here is going to get multiplied by this column right here, right? So this row here is going to get multiplied by this column right here. So I'm going to have the summation of, see, this is 1 1 1 1 1. So that means the a of 1 is actually a constant, and the next is actually kind of a variable from 1 till n. And this one over here, it's b of, you can clearly see that it's going from b of 1 1, b of 2 1. So this one goes like j, and the next one is actually a constant, which is actually equal to 1. The next one over here, if I want to write this one, now this row again is going to get multiplied by this column here, this column here. So this is going to be, the next one is going to be the summation of a of similarly the same thing, but for b it's going to be this is going to be j into 2, right? So b of j2. The next one is going to be similarly, likewise it's going to go, and we're going to have the multiplication of the last one, that is of a1i into b of j and p. So it's the pth column, right? Similarly, you're going to have the next one like this, and the last one is going to be the multiplication of this last column with the first column. So that is going to be a of the mth column into I into b of jth column into 1, and likewise it's going to be the last one. The last number is going to be the multiplication of the last column with the last number, that is going to be a of mi into b of, similar to the last one, which is actually equal to jp, right? And it's going to be the order of m into p, because this is same, and this is what is going to be their order. So let's go ahead and kind of multiply it together. Let's suppose we have kind of a matrix here, which is actually of 1, it's actually 1 minus 1 and 2, 0 3 and 4, which means it's of an order of 2 rows and 3 columns. And we have another matrix B, which is 2 7 minus 1 and 1, and we have 5 and minus 4. It's of the order of 3 rows and 2 columns. You can clearly see this 3 is equal to 3. That means our product here is actually going to come out of the order of 2 into 2, which means this is going to be 2 into 2. So this is going to get multiplied by this first. So we're going to have 1 into 2, which is 2, minus 1 into minus 1, which is 1, and we're going to have 2 into 5, which is 10. Then we're going to have this one here, that is 1 into 7, which is 7, and the minus 1 into minus 1 is actually minus 1, 4 into minus 2 is actually minus 8. This one over here is going to be this over here into multiplied by this, which is going to be 0 into 2, that is 0, 3 into minus 1 is negative 3, 4 into 5 is actually 20. And then we're going to have this into this, that is 0 into 7, which is actually 0, 3 into 1, which is actually 3, and 4 into negative 4 is actually negative 16. So this is going to come down to be equal to 13 and negative 2, and 17 and negative 13. So that is going to be the multiplication, that is A into B, for these two matrices, right? So I suppose you're understanding this point over here, guys. And let's try to find let's try to find the matrix using the same matrix. I'm just gonna do one thing, just gonna remove this here. Now using the same matrix, that is matrix A, which is actually equal to 1 minus 1 and 2, and 0 3 and 4, so that is of an order of 2 rows and 3 columns. And we have another matrix B, which is 2 7 minus 1 and 1, and 5 and minus 4, that is actually of an order of 3 into 2. Now instead of finding A into B, let's try to find B into A. Now for B into A, if you try to find B into A, the order of B is actually equal to 3 into 2, and the order of A is actually equal to 2 into 3. So that means 2 is equal to 2, which means they are gone. Now B into A is actually going to be of the order of 3 into 3. So you can clearly see here, B into A is actually going to be an order of 3 into 3, which means that A and B might not be equal to B and A, which is actually going to be true for so many matrices. This is actually true for all the non-square matrices. So that means A into B might not be equal to B into A. So that property is not there in your that property is not there in the matrices. Now if I want to multiply B into A, what I'm going to do is I'm going to multiply this row with this column here. So I'm going to have 2 into 1, that is 2. Then I'm going to have 7 into 0, which is actually equal to 0. Then what I'm going to do is I'm going to multiply this row into this column here, because I'm doing B into A. So row and column, that is how it's going to work. So 2 into minus 2 is going to be minus 2, and 7 into 3 is going to be 21. Then you're going to multiply this row into this column here, which is going to be 2 into 2, which is 4, and 7 into 4, that is 28. Similarly, you're going to multiply this row into this column here, which is going to be minus 1 plus 0, which is going to be 1 plus 3, so you're multiplying this into this, which is going to be negative 2 and positive 4. Then you're going to be multiplying this row into this column, which is going to be 5 plus 0. The next one is going to be negative 5 and negative 12. And the next one is going to be 10 minus 16, right? So I suppose you're understanding this point over here, and clearly we know that A into B is actually not equal to B into A. That means the matrix multiplication is not commutative. So this is actually a property of commutation or commutative. So the matrix multiple is not commutative, right? So this just not commutative for this instance. It might be commutative for some other instances. What if I multiply, the value of A is 1 1 0 0, and the value of B is again 1 1 0 0. Then A into B will actually be equal to B into A. So in that case it will be commutative, but in this case it is actually not commutative. So let's talk about the properties of multiplication of matrices. Since we already know now what multiplication is, so what are the properties of multiplication, just the way we have actually done the properties of addition? So first of all, it follows the associative law, right, which states that A into B into C is actually equal to A into B into C, right? So this is actually there, but just to make sure that it follows associative law, the matrices have to be completely defined, which is actually very, very important. It follows the distributive law as well, which states that if matrix A into B into C is actually going to be equal to matrix A into B plus matrix of B into C. So that is going to be there. And there will be a multiplicative identity as well. So what do you mean by multiplicative identity? Multiplicative identity means that that if, let's suppose, there is a matrix I of some particular order, then such that I into A is equal to A into I, which is actually equal to A. So I is some sort of a matrix, and I into A would be equal to A into I, which will actually be equal to A. So that is known as the multiplicative identity of a matrix. This I matrix is known as the multiplicative identity of a matrix. So suppose you're understanding this point over here, guys. With this you can actually solve a lot of questions when it comes to multiplication of matrices, right? So that is there. And I suppose you're understanding this point over here, guys. And thank you very much for watching this video. This would be the email address to explore more about us, that is perfect-scores.com. This would be the Facebook page to give us your valuable like, and this would be the email address to send us your valuable feedback. So thank you very much for watching, guys. I'll see you in the